In this segment, we're going to talk about interpolation. So, let's say I want to know the saturation pressure at 5 degrees Celsius. Well, I can read that directly off of the tables. I can go to my saturated tables that are organized by temperature and read off the saturation pressure at 5 degrees Celsius. And it looks like it's 0.00872 bar or 0.872 kilopascals, no problem. But now let's say I want to know the saturation pressure at 6.5 degrees Celsius. Kind of looks like I have a problem because I don't have a row for 6.5 degrees Celsius. I need some way of filling in that information so that I do have a row for 6.5 degrees Celsius. So what I'm going to do is interpolate. If you look at your saturated water table and you look at temperature and pressure, so the temperature and the saturation pressure, and you graphed those, you would see that the relationship between them is not a linear one. However, if you zoomed in on a really small segment of that curve, you could approximate it as linear. So that's what we're going to do. So here's my zoomed in segment of that curve that I'm approximating as a line. And what I'm going to do is I'm just going to put my coordinates on this. So the first coordinate would correspond to 6 degrees Celsius and the saturation pressure at 6 degrees Celsius. And then the other one would be 8 degrees Celsius and the saturation pressure corresponding to 8 degrees Celsius. And then the last coordinate would be in the middle, and that would be 6.5 degrees Celsius. And then the thing that I don't know yet, that y coordinate, which is the saturation pressure at 6.5 degrees Celsius. So I've got 3 coordinates on a line. This is my new chart. This is the information that I need to fill in. I need to fill in the line at 6.5 degrees Celsius. So this is the same information on the previous chart that you saw, just kind of in a nicer format. Okay. Now what you'll notice is that if I looked at the line connecting any of these dots, they would all have the same slope. So the slope is defined as delta y over delta x, which in this case is the change in the y coordinate, which is p sat at t, and then the x coordinate would be delta t. So let's look at that. So if we look at the line connecting the outer two dots, the outer 2 coordinates, that would be between 6 and 8. So my slope would be delta y, which would be 0.01072 minus 0.00935 over 8 minus 6. Now just a word of advice, you need to make sure that you don't get any of these numbers flipped around. You need to be consistent in how you're defining delta y and delta x. So what I do is I make a chart just like this one, and I work from the bottom to the top. So delta y, well, the bottom coordinate on my table is 0.0172 minus 0.00935. And then I look at the denominator. Bottom is 8 minus 6. All right, so that's my first slope. I could look at another slope, and that would be between the coordinates for 6 and 6.5. So looking at my chart again, working from the bottom to the top, it's delta y is p sat at 6.5 minus 0.00935. And then for the denominator, delta x, 6.5 minus 6. And then the last line would be the line between 6.5 degrees and 8 degrees. So once again, the numerator, delta y, would be 0.01072 minus p sat at 6.5 degrees Celsius. And then for my denominator, 8 minus 6.5 degrees Celsius. So I really only need two of these definitions. So I'm just going to arbitrarily pick those first 2 and set them equal to one another. It doesn't really matter which 2 of those you pick. You could pick any one. So if I set them equal to one another and then I just solve for p sat at 6.5 degrees Celsius, I ended up getting 0.00969 bar. And you can double check and make sure that that makes sense. Whatever you calculated in red there, it should be between 0.00935 and 0.01072, and it is. So it looks like we did everything correctly. double interpolation. So let's say we want to know the specific volume of water at 1.3 bar and 180 degrees Celsius. So I'm going to write all this stuff down, given find assumption solution, and I need to figure out what my phase is. So I need to go to my saturated water tables. I could go to the ones that are organized by pressure or temperature. It doesn't really matter. Looks like I just arbitrarily picked the ones that are organized by temperature. Go to 180 degrees Celsius and I see that my saturation pressure is 10.02. So in order to be saturated at 180 degrees Celsius, I have to be at 10.02 bar, and I'm at 1.3 bar, which means I'm superheated. So I need to go to my superheated tables. So here are my superheated tables, and I need to look, remember everything's organized in blocks of pressure, so I need to look for the block corresponding to 1.3 bar. Uh-oh, it's not on there, but I do have boxes for 1 bar and 1.5 bar. So let me kind of, I'm taking those two boxes and I'm just kind of moving them close to one another. So this is what you have in your book, and I've just kind of put them close together so it's easy to see. So what I normally would do is I'd say, okay, well that's fine. I'm going to make my own little table and I'm going to organize it however I want to. I'm just going to, I know that the pressure is 1.3 bar and I've got information for 1 bar and 1.5 bar. So I'm just going to interpolate using the data at the 180 degree temperature line on each of those boxes. But the problem is I don't actually have a line for 180 degrees Celsius on either one of those boxes. So what do I do? Well, what I'm going to have to do is I'm going to have to do a double interpolation. I'm going to have to fill in that temperature information on each of those boxes. So I'm going to have to create a line for 180 degrees Celsius and 1 bar and 180 degrees Celsius and 1.5 bar. All right, so looking again, same table. I'm just kind of putting it over to the side here. So at 1 bar, I need to figure out what the specific volume is at 180 degrees Celsius. And at 1.5 bar, I need to fill in the information for 180 degrees Celsius. So I'm just doing an interpolation. Same thing that I did before. It's just difficult. The only difficult part is just knowing how to set up the calculations. So here I go. I interpolate. No big mystery here. It's the exact same thing that you did in the previous problem, and I'm just filling in that first block for 1.4 for 1 bar at 180 degrees Celsius, and then I just need to do the same thing for 1.5 bar. So I've interpolated. I get a specific volume of 1.381 meters cubed per kilogram. So there's my temperature data. It's all filled in. Now I have data for 180 degrees Celsius for each one of those guys. And there's my new table that I'm filling in. And I'm just bringing the information from what I calculated in those top 2 tables and putting them in my new table. So I'm looking at the specific volume at 180 degrees Celsius. So this is all for 180 degrees Celsius, corresponding to 1, 1.3, and 1.5 bar. And it's just another interpolation. So 2.878, that's where that one comes from. 1.381, that's where that comes from the 1.5 bar table. And I just need to interpolate. And I got 1.660 meters cubed per kilogram. And you just need to make sure, do a gut check. Does all of this make sense? Are the numbers that I interpolated, do they make sense? Are they between the numbers that I interpolated between? So that bottom table, I know that my specific volume at 1.3 bar and 180 degrees Celsius, I know it needs to be between 2.078 and 1.381, and it is. So that's my answer. All right, well, I hope that was helpful. Let me know if you have any questions.